Hello, today we keep talking about the substitutional. Okay, last time we talked about only the algebra, the number substitutional. Today we're going to talk about the substitution with trigonometric function or trigonometric identity. Okay, so in example 6, they give here cotangent 7x. Okay, how we can change it? Actually we cannot do right away. We should change a little bit because we know that, which means cosine and cotangent x mean cosine x over sine x, right? Everyone knew it, right? So that idea, this one you can change. How we can change? Cosine 7x over sine 7x dx. Okay, and substitutional. So let's say let u will be 7x, or it doesn't matter, but I think just follow the book way. But 7x is fine too. But this book say sine 7x. Okay, this one too. I think it's a little simpler. And derivative both sides. So du will be 7 cosine 7x dx. Right? So one more. Du over 7 equal to what? Cosine 7x dx. Right? You can see that. Now is a substitute. So how can I substitute? Here, let me change the color. You need to see that. Hold on. This color. Okay. So this part is cosine 7x equal to du over 7. Okay, and that one will be here, right? Can you see that? Alright, now just plug in. Okay, so integral denominator will be just u, and numerator part cosine 7x dx will be, we mentioned that, over 1 du over 7. Okay, which is 1 over 7 integral du over u. That will be what? Sorry, put in should be out here. So 1 over 7 and then absolute value u plus c. And finally, u is sine 7x, right? So 1 over 7 and then absolute value sine 7x absolute value plus c. Okay, plus c. Typing. Okay, anyway, right? So turn the color one more time. Alright, so back to the u value, right? So only you knew it. 1 over u changed to integral. Ln, right? Which means ln u derivative will be 1 over u from here. Okay, do you understand? So right now, using substitutional way for trigonometric function. Okay. Next one. Let me change color first. Need to compare. All right. So also here, denominator trigonometric function, right? So how we can do that? But this is pretty simple. You may know, I think you know it. right? So let me change that. Simply cosine, one of cosine will be secant, right? Secant square x and dx. Oh, it's supposed to be 2x. Alright, sorry. There's 2 denominator here. Maybe 2. Sorry, I should typo. But anyway, right now, if you out too much easier. So let's say we're gonna try to use substitution array. Let's say u will be 2x. If you just want x, you don't have to do that way. And du over 2 will be just dx. Right, and just plug in. So integral secant square just u du over 2. Okay, so 1 over 2 in front. And how much is the secant square? Will be tangent. So tangent u plus c. So how much u? 2x. So 1 over 2 tangent 2x plus c. Okay, this one was a substitution array. Okay, alright. Next one. This time cotangent square 3x. Okay, square. So you know the cotangent. How can I do that? That time we're gonna using Pythagorean identity, which means may you still memorize cotangent square x plus 1 equal cosecant x square. Alright, so using that way, equal to from here to here. Okay, integral separately. What's that? Cosecant x square minus 1 dx. Okay, so we know the cosecant square means. So right now, this sorry, 3x. Okay. So substitution way, let u will be 3x and du over 3 dx, right? And plug in integral cosecant square u minus 1 1/3 in front maybe, and dx. Okay, right now integral 1/3. How much cosecant square? That will be negative cotangent u minus u plus c. Now substitute 1/3 negative cotangent u means 3x, u means 3x plus c. So finally negative cotangent 3x over 3 negative the x plus c. Okay, that is our integral. Okay, so in this case, okay, let me change the color for red. Okay, in this case you should know Pythagorean identity, and here substitute and calculation. Not bad, right? Alright, next one. In this case, it's cosine cube, not cosine square, cosine cube. So the cube will a little bit spread out, which means, oh, change color. So blue. Okay. So integral cosine square cosine square x times cosine x dx, because it's cube, so spread out square and just 1. Now substitution way, so let okay, let u will be cosine, no, do one more time, sorry. In here, change to 1 minus sine x squared cosine x dx. Okay, so our substitutioner, we're gonna choose in this case sine x, and du will be cosine x dx. Alright, can you see that? We're trying to make this part make it simply like du. Okay, so substitutioner, so integral 1 minus u square du. Can you see that? Much simpler. Okay, and integral u subtract u cube over 3 plus c. Right? And then what's the u? Just plug in. Last step. U will be sine x subtract sine x cube over 3 plus c. Right? Understand? So our part, we make a 2 part here and here, because we are using substitution way. So x cosine x square identity 1 minus sine x square, and substitute. Okay, can you follow me? Right? It's not hard, right? Move on. Next problem. Next problem is definite integral. Definite integral. So before they have a c, because we don't care what kind of number. Right now we care that, which means they give us low interval, no boundary, upper boundary they given. So if they given like here upper boundary and low boundary, which means there's no c, we can find the number. Alright, so before that, tangent secant square, there is something of relationship, right? So substitution way, let maybe u will be tangent x and du will be secant x squared dx is tangent. Wow. Okay. Not finished yet. Before we finish that, because they at the time before they have no boundary, upper boundary. Right now they given. So when x value pi over 3, how much u value? Answer from here. Okay. So just plug in how much it will come out. That will be square root of 3. How about x when x is 0? U will be also 0. Right now, we can plug in right now. I mean substitution. So first of all, upper boundary pi over 3 go to square root 3. 0 go to 0, same. And tangent to x will be u, and du will be secant square. So from here to here, it's going to be du. So simply u du. Looks much easier, right? So now this one integral, how much will be 2 u square for boundary square 3 0. You may know, right? Just plug in upper boundary, subtract lower boundary. So here plug in square to 3 square, which means 3 over 2, and 0 will be 0. So it will be 3 over 2. Okay, this is also substitution way, definite integral. Okay, will be okay. All right, one more question for last question for today. So also this time absolute value again. All right, so trying to substitution way. So denominator and numerator something have relationship. So maybe let u will be x squared minus 4. Okay, when derivative du 2x dx. When you see the numerator only have x, so we don't need 2. So d over 2 x dx. Okay, I told you it's not finished yet, right? So when x will be 1, how much u value? Plug in here, right? This value. So negative 3. How about x? When x value 0, u will be negative 4. Right? Now we just plug in. So upper boundary 1 go to negative 3. Lower boundary 0 go to negative 4. And numerator part is we say u, and denominator part, sorry, numerator part x will be x dx du 1 2. So du over 2. So which means 1 over 2 integral negative 3 and negative 4 du over u. Okay. So we change it. This is natural law. So 1 over 2, and change it to ln absolute value u negative 3 negative 4, and just plug in 1 over 2 ln 3 subtract ln 4. One more, 1 over 2 ln 4. That's it. Alright, can you see that? Okay, so this one also on a point will be, we should decide which one to substitute. So usually denominator part make the u, and you should check it when the denominator part differentiate, should come out some number as a numerator like that. So we change substitutional, right? Substitution part, and then change to upper limit and the lower limit, and substitute. And the rest of them the same way. Alright? Alright, I'm gonna give you homework too, so you should solve it yourself. If you have a question, let me know. Send an email or talk to me, I can help you. Also, don't forget, we have a class. At the time you have asked me more. Alright? Alright, bye bye.